Hi guys, welcome back to my channel Programming with Pirai. In this video, we are going to see about the Lego question number 543, diameter of a binary tree. Given the root of a binary tree, return the length of the diameter of the tree. The diameter of the binary tree is the length of the longest path between any two nodes in a tree. This path may or may not pass through the root. The length of the path between two nodes is represented by the number of edges between them. Okay, let me show the example. So see here, this is the first example. In first example, what is the maximum path I can go from one node to another node? So I can say this is one of my maximum path, right? From this 4 to this 3 is one of my maximum path, and from this 5 to this 3 is also another one of the maximum path, right? Okay, both will be giving what? Output as 3. Because see here, 1, 2, 3. Okay, here also 1, 2, 3. So I can say the 3 is my output. Yes. Okay. See the second example. In second example, one of my longest path is what? This, from this 2. So this is the longest path, and this is the longest diameter also. Other than that, whether we have any other, no, right? See here for this 1 also, from the 6 to pi 1, then 2, then 3, then 4, then 5, only 5. But here we got what? 6. So what is the output? It is 6. Okay. In another words, we can say that if this 2 is my node, is the current node, then I want to calculate how many nodes are at the left subtree. How many nodes are deepest? What is the deepest node? And between them, how many nodes are in the left subtree? And also, what is the deepest node here? It is 9, right? So from this 7 to 9, how many nodes are present? Totally 9. So sorry, totally 3. So 3 plus 3 is what? 6. Can you understand this? Okay. Let me take this example. From this one, if I choose the left subtree, it is what? I can either choose this 2 and 4 as one path, or I can choose either this 2 and pi as one path, right? If I choose this 2 and 4, it is what? 2. And if I choose this 2 and pi, what is the path? It also the longest path will be 2, right? Okay. In right subtree, I can choose only 1. So it will be what? 2 plus 1 is equal to 3. So 3 is my output. Can I understand this? If I want roots, what is the diameter from the root, then I can say that the maximum path from the left subtree plus the maximum path from the right subtree. That's it. Okay. Now let us see the example. See here, my first approach is this is my first node, right? This is my first node. From this node, I want to calculate what is the maximum diameter I can achieve. So I can say here I can take this 2, or either this 2 also, anything will give what? Only 2, right? Okay. And here it is only 1. So I can say 2 plus 1 is equal to 3. So 3 is my output, right? So 3 is my one of the maximum. Yes, again. I will go to this 2, and I will check whether this 2 has a maximum diameter. Okay, let us check. It has 1, then 2. So it only has what? 2, but our maximum was what? 3. Okay, now I'm going for this 4 and checking whether what is the maximum diameter? It is 0. And for this pi, it is also 0. And for this 3, it is also 0. So I can say the maximum diameter is what? 3. So what I am doing here, I am placing my pointer on one node, and I am checking what is the longest path at the left subtree and longest path on the right subtree. And I am returning that as our max. Can I understand this? So this is the first approach. This is what? A brute force approach, which lies between time scale of O of n square. And space function will be what? O of h, where h is the height of the binary tree. Can you understand this? Okay. See here, for this one, we want to find the height of this 2, right? Sorry, the diameter of this 2, or the longest path of this 2's subtree and right subtree. Left subtree and the right subtree, right? So to find one's diameter, what should be my formula? I want to put like, what is the maximum among 2's left subtree, 2's right subtree? Yes, plus what is the maximum among 3's left subtree and 3's right subtree? Right? This 2's and this 3. So I want to calculate this such that I can conclude with what is the maximum diameter I get, right? get the maximum diameter, and I want to include these two nodes also. So I will do what? 2 plus. Can I understand this? Can I understand this? Okay. And for this 2 again, we want to find the 4 and 5, right? So approaching from top to down, can we approach from bottom to up, such that we are just making the problem into a sub-problem, and we are finding the sub-problem solution and finding the main problem solution. Okay. Now let us take this as our tree node. Okay. Now I am at this one. I am at this one. Now I am going to do a post-order traversal such that I will traverse first, then only we want to compute it, right? Okay. Traverse. So I am going here. Again, it will be here. Okay. I am at this 4, right? I am at this 4. So seeing this 4, we can say that it doesn't have any left. Yes. Also, it doesn't have any right, right? Okay. I am going to left, first of all. Left is what? Null. And right is what? Null. So I am checking this 2 such that I will give what? I will give this return 0. This also return what? 0. If it is null, I want to return 0 because there is no more path, right? So I return 0. So what is the maximum of 0? I can say it is also 0. So the diameter of this 4 is 0. So let me take the result and keep as 0. Now this 4 sends this to like my maximum path is 0. And take myself also. It means what? 1 plus 0. So it will be what? It's sending 1 to it. Okay. Again, this 2, again, it goes here, right? In post-order traversal, we will go for what? Right side. Okay. Now for this 5 also, here and here is null. So this null gives 0. This null gives 0. So I can say, what is the maximum among this? Sorry, what is the addition of this 0 plus 0? It is also 0. So I can say diameter of 5 is 0. And this 5 will return what? Will return 0 plus 1. What is the maximum among this? What is the maximum among this left and right subtree path? So I can say it is 0 plus 1. Just include this pi also, right? So plus 1. So it returns what? 1 only. So for this 2, I can say the diameter is 1 plus 1. 1 is the left subtree and 1 is the right subtree's longest path. I can say that it is 2. So it will be updated as 2. Okay. Now what should this 2 will return? Okay. Just observe this. What is the maximum among the path of the left subtree? It is 1. What's the maximum path along the right subtree? It is also 1. So maximum will be 1. And take this 2 also. So it will be what? 1 plus 1 is equal to 2. So this left subtree of this 1 return what? 2. And we want to go for what? A right subtree, right? Okay, for this right subtree, I am going here also null, here also null. So it also returns 0, it also returns 0. And this 3 returns what? 0 plus 1. Maximum among them is 0. So 0 plus 1 is what? 1. So for this first node, what are the return value? From the left subtree, it is 2. From the right subtree, it is 1. So 1 plus 2 is equal to 3. So 3 should be my current result. 3 is the maximum, right? Okay. Now, it also return what? The maximum among this 2 and 1. What is the maximum among this 2 and 1? It is what? 2. So it returns 2. Okay. That's the longest path. See here, this is the longest path, right? From the left subtree, there are 2 longest paths. That's why returning what? The longest path is what? 2. Okay. And we computed the answer in our result only. We doesn't compute it in our return, but we compute in the result only. Okay, this result should be a global variable, or it can be an enclosed variable if you are using a Python inside a function. Okay, now let us take this example. I am currently at this node. Okay, now I am doing a post-order traversal, right? I am going here, going here, going here, going here. At last, I am going to the null value. So it also null, and here also null, right? Okay, it returns what? 0. It returns what? 0. So for the 6, I can say the diameter is what? Diameter is 0. So initially the result is 0. Now, the 6 returns like, okay, my longest path among the left and right is 0 and 0. So the longest path is what? 0 and include myself. So it will be what? 0 plus 1. So 1 will be returned for this pi left subtree. Then it goes for right subtree. It is what? Null. So it returns what? 0. So for this 5, what's the diameter? I can say diameter is 1 because 1 plus 0 is 1, right? So this result will be updated as 1. Now, what should this 5 return? This 5 return a maximum among this 1 and 0 plus 1 because this 5 also included in the path for this 4, right? So it will be what? 2. It returns what? 2. Okay. Now, this 4 goes to this right subtree. It is what? 0. Sorry, null. So it returns out what? 0. Okay. So 2 plus 0 is what? 2. So As of now, what's the maximum path again? What's the maximum diameter again at type? It is 2. And this 4 returns, what is the maximum among 2 and 0? It is 2 plus 1 because we are including this 4. So 2 plus 1 is what? 3. So I am returning 3 to this second node. Okay. Now it goes for what? Right side. Because it's a post-order traversal, right? Right side. Then it goes for the left side. But the left side is what? Null. So it is what? 0. Now it goes for the right side. Again it goes for the left side. It is what? Null. Again it returns 0. Again it goes for right side. Okay. Now for this 9, it is null. It returns 0. Right also null. It also returns 0. For this 9, I can say the diameter is 0, right? Okay. What is the maximum among this 0 and 0? See here. This 9's diameter is 0. That's why I'm not updating in this result. Okay. Don't forget. Now 0, 0 and 0 are the maximum path, right? What is the maximum path among this? It is also 0. So this 9 will return what? 0 plus 1 is equal to 1. Okay. Now this 8 will be what? 8's diameter will be what? 0 plus 1. 0 plus 1 is what? 0 plus 1 is 1. So this 8 diameter is 1. And this 8 will return what? Maximum among this 0 and 1. What's the maximum among this 0 and 1? I can say this 1. Right? Sorry, 1 plus 1 for this 8 itself. This 8 also included in my longest path, right? So it will be 2. It will be 2. Now, for this 7, the left subtree is 0 and right subtree longest path is 2. So 2 plus 0 is 2. Our result is also 2. So don't want to update it. Now, what should be this 7 will be returning? This 7 will be returning the maximum among this 0 and 2 plus itself. So it is 1. So it is what? 2. So this 7, that is the right subtree is also returning 3 and left subtree is also returning 3. So 3 plus 3 is equal to 6. So hats up now, what's my result? It is turned into 6. Okay. Now, what should this 2 returns? This 2 returns maximum among 3 and 3. What it is? 3 and 3. So 3 plus 1 for what? This second node also. Including this second node in the longest part, it will be what? 3 plus 1 is equal to 4. So it returns 4 and we want to go through the right side, right? For this, it is also null. It is also null. So it returns also 0 and this side returns 0. So what is the maximum among them? It is 0. So I return what? 0 plus 1 is equal to 1. So for this 1, I can say my left subtree's longest path is 4 and right subtree's longest path is 1 and it should be what? 5. Whether the maximum is 5? No, it is 6. So you don't want to update it. If it is less than 5, you want to update it. Okay. Now, this 1 also written what? Maximum among the left subtree and right subtree. What is the left subtree maximum? It is 4. What is the right subtree maximum? It is 1. So 4, 1's maximum is what? 4 plus 1 by itself. So it will be 5. So it just written. But we want to take this result back. Hope you understand this. So what is the time constraint space multi per solution? I can say my time constraint will be O of n because I am traversing each and every node only one time. And what is my space of t? I can say it is O of h because I am using what? A recursion stack space. But which is what? Yeah, internal stack to do a recursion call, right? Okay. Let us see the code. It will be more clear. See here. First result is equal to 0. What is this result? This result is a enclosed variable. That's why I'm using what? Non-local inside the DFS function. Now, if there exists no root, then I would return 0. And if L is equal, if the root is null, I will return 0. Yes, that's what I told in the drawing explanation stuff. Right? Now, L is equal to, I'm going a DFS call for root left. Again, R is equal to DFS call for roots right. Okay, now, result is equal to maximum among L plus R, comma result, which means what? I'm just taking the sum of the longest path from the left subtree, the longest path from the right subtree, and I'm doing the addition. And I'm just taking the maximum among them, like the result in that computation. Now, I'm going to return what? 1 plus maximum among the left and the right subtree. I want to take either the left longest path or right longest path plus 1 by adding the root itself as a longest path, one node. Okay. Now, I'm just calling the DFS function. Then I'm returning what? The result. Here, see here, I'm returning the result. I'm not returning the return value of this function. Okay. Let me submit it. Yes, it is submitted successfully. Thank you.
And the other dot nom.
And then we didn't feel it.